Here we have a vibrating string, vibrating due to a mechanical oscillator connected to a frequency generator. At the other end, we have a pulley with a weight providing tension. That's 350 grams. Using the meter sticks, it's a distance of 4 meters from the pulley to the oscillator. We have a node at each end. So how many waves is this? Half a wave. What's the wavelength? Well, if the distance is 4 meters, the wavelength has to be 8 meters. You can use the frequency times the wavelength to get the velocity of the waves on the string. But then there's another way of getting the velocity of the waves on the string. You can use the formula for the velocity of a wave on a string under tension with a linear mass density. The tension can be found from the weights on the end. The linear mass density is the mass of the string divided by the length. And that's got to be the length of the string while it's stretched. I have the same amount of string on top of the scale. It reads 11 grams. Now, the reason why I have some of it hanging off is to account for the part that's not being stretched out between the pulley and the mechanical oscillator. So the amount of string on the scale is now being stretched to 4 meters. You do the math and see how close it is. Well, I can change the frequency and see what happens to the wave. It's not resonating well. Definitely not so good. But at 4.6, we have a nice fundamental wave. So what would I have to do to get to the second harmonic? Here I am at 8.6 hertz. Not so great. Oh, I got it dialed in at 9.2. Yes, we have it. You can see that there's a node right in the middle. There's a node right here. The waves are passing right through there. I have an antinode here and an antinode there, or otherwise known as a maximum, and the node in the middle. How's that look? I know the frequency, and now the wavelength has to be 4 meters. That's the distance between the two ends. There's only one wave standing there. Do I still get the same velocity? At 10.2 hertz, not as good. But check out 13.8. We now have a node here, a node here, and then there we have the end of the string. We have 3 half waves. We're at the third harmonic. Yeah, that's a good node. That's a strong maximum. Where will the next harmonic be? Looks like we have something. Half a wave, half a wave, half a wave, and half a wave. We have 2 waves standing here. What do you think the frequency is? 18.4. It doesn't work so well if we don't line up the frequencies just right. Here we are with 5 half waves. Go calculate the frequency. Did you get 23? It works well. Look at that node. Now we can have a little fun with the strobe light. The blinking of the strobe light freezes the action just for a moment. I can adjust the frequency of the strobe light and slow things down. I've got the string stopped now. Now I have it moving very slowly. Well, the string really isn't moving slowly. It's going really fast. I can feel it hitting my finger. It's just that the strobe light freezes the action. Hey, there's the node. There's the maximum. We can demonstrate the strobe effect with a spinning weight. Is it really reversing direction? No, it's just spinning like this. But the strobe light can give it an effect like it's freezing the action and then reversing. All right, it looks a little better in real life. Good luck with the calculations, everybody.